with the successful skateboarder, his the speed stayed consistent the entire time, and he stayed parallel to the board the entire time. His body wasn't like slanted in comparison to the board at any point in time, and the board was, of course, always on the ramp. But with the unsuccessful skateboarder, he was like slanted compared to the board, and he kind of seemed to like flip off of the board, and the board kept going just for a little tiny bit. And his speed seemed less consistent as well. So what I was thinking is that possibly the inconsistent speed could like attribute to some unbalanced force, and the skateboard could keep going, and he would like go a different direction or some such thing. I mean, that's just like my first, right off the top of my head, speculation.
Do you think the position of the skateboarder could affect why he doesn't fall?
Well, definitely, because like, you know, if you have like your little ramp, and then you have your little skateboarder right here, you know, and here's your skateboard. If he is like looking this way, and is like leaning forward, that's gonna be more aerodynamic than if he was parallel, you know. So definitely the stance affects it in a certain way. So, you know, and when I say his body was parallel to the board the entire time, I don't mean that he was just like standing up straight. I mean that like he wasn't like off to the side or anything. So maybe parallel isn't the right word for it, but you understand what I'm saying. He wasn't like offset from the board. He was always like with the board. He was like one with the board the entire time. And I feel like that's a big part of the reasoning. I feel like the forces became unbalanced because he stood on it the wrong way and traveled with it the wrong way. And you know, an object in motion tends to stay in motion, so he kind of flipped off it and it kept going and such. And you know, so the same amount of force was put on both of them, just in different directions, is my speculation.
So do you think the size of them could affect how?
Well, the size of the loop probably could, because then you'd need like more force to get all the way around, and you know, then you'd probably need to find a good way to keep a steady positioning, to keep going at a consistent speed all the way around. And if the loop was too big, you'd probably fail, because you know, then gravity would probably like even you out and bring you down.
So did you notice the change in forces that each of the skateboarders put into their?
I didn't really pay attention to the amount of kicks or which feet they were using or anything like that. I probably should have. I should look for that next time.
And 5, 4, 3, 2, 1. Eyes on me. Thank you. Observers, it's your turn now. You're going to give your feedback. Make sure you're saying why they got the score they got using the evidence that you just collected with your notes. Tell your explainer question or how they do, why, and what could make them better. Ready to go.
Okay, I would say that you got a high 2 because you had the why. It was almost like you were really close, but you couldn't quite describe it because we haven't learned about this yet. Because you didn't really talk about what we can't see, you mostly talked about what we could see, and you did a really good job explaining the observations and the how, but you were almost to the why. You were almost to a 3, but not quite.
Pretty much almost to a 3, yeah. Like, you had a little bit on unbalanced forces and things, but not really much of else. Like, the size of loop and things like that, we can actually see that, so I think it's, like, really close.
Not quite
Maybe
there.
just a little
You need to talk a little bit more about the forces involved, but it's hard because we haven't learned that yet.
Right.